Hi guys, today we're hopping into the world of rational functions. But don't worry, we're just focusing on where the graph touches or crosses the x-axis, the zeros, and what the graph does at its ends, which is end behavior. I'll walk you through on how to find the zeros and more. Today we will be talking about two topics, 1.7, which is rational functions and end behavior, and 1.8, rational functions and zeros. So what are rational functions? Rational functions are a ratio between two polynomials, and in the example here, p of x over q of x. P of x determines the zeros, and the q of x determines the asymptotes, and both of them together determine end behavior and wholes. Okay, now on to end behavior. So if the degree of the numerator is less than the degree of the denominator, for example here, it's x to the first power and x to the second power. So that means the limit as x approaches infinity, f of x equals 0. And you can see that here where it's getting closer to the x-axis. And then on the left side, limit as x approaches negative infinity, f of x also approaches 0. So both of them are getting closer and closer to 0, but never reaching it. And then that is called the horizontal asymptote, which is at y equals 0. Next, when the degree of the numerator is greater than the degree of the denominator, like here shown, the degree is 3, and on the bottom it's 1. So that means the limit as x approaches infinity is going to be plus or minus infinity, depending on the positive and negatives. So on the example here on the left, it's towards infinity on both sides. And then on the example on the right, there's a negative here. So it will approach negative infinity on both sides. And then to test this out, you can plug in really big numbers and see what will result. So let's say we plug in 100 cubed over 100 plus 1. And that's going to increase when we get big because the numerator increases at a rate faster than the denominator. And for the other one, it's just the negative version of that. So it's going to be the same but going downwards. Another end behavior is when the degree of the numerator is 1 greater than the degree of the denominator. The limit as x approaches infinity will follow along the remainder of p of x divided by q of x, which is a line. And that's why it's called the slant asymptote. And then in the example we have here, x cubed plus 1 over x squared, the remainder is just x. And you can see the end behavior follows along the line y equals x. Lastly, one end behavior is when the degree of the numerator and the degree of the denominator are the same. So then that means when x approaches infinity, f of x approaches the ratio of their leading coefficients. And then the same for the left side when x approaches negative infinity. So here we have an example. The leading coefficient is 1 on the top and the leading coefficient is 3 on the bottom. So then you can see on the graph that the end behavior is approaching the asymptote, the horizontal asymptote y equals 1/3. Now we're going to talk about zeros, which are where the graph intercepts the x-axis and y equals 0. So the zeros are the roots of the numerator. And here in this example, it's x equals -1, 2, and -3. So you see they're plotted here, and then the graph goes through them. And the denominator does not affect this at all unless there is a common factor that you can cancel out. Now it's time for a practice problem. So we are given the graph of a rational function, and then we need to answer questions. Okay, so we look at the questions. It says write limit statements about the end behavior. And what asymptotes does this graph have? So these are limit as x approaches infinity, which is here, f of x approaches 0, and limit as x approaches negative infinity, which is over here, f of x also equals 0. And what kind of asymptotes does this graph have? This graph has vertical and horizontal asymptotes. So the vertical asymptotes are here, and the horizontal one is right here. Okay, and then next we need to identify all zeros and what they're from, where they're from. So the zeros are here, -1, and that's it. So that's the only zero. And then the 0 is from the numerator, where it's the root of the numerator, and it's where the function crosses the x-axis. You did it! Now you know how to find the zeros and describe the end behavior of rational functions like a pro. If this helped you, tap the like button, hit subscribe, so you don't miss any videos in the future.